Hey guys, Mr. Murphy here. So we ended the last one with this right here, where product rule of exponents. If I have x times y, both of them raised to a power for any numbers, then I can split up x to the power times y to the power. Okay, x to the y raised to a power is same as x to the power times y to the power. And I prove it by saying, well, if I have xy to the z power, that means xy times, and I can move them around using commutative power. So I have all my x's here and all my y's here. Then I can split them up and say x is z times, y is z times. So x to the z, y to the z. Or 17, because for some reason I wrote 17 instead of z. All right, so let's look at some strange cases. What if I have three numbers, three terms inside here? So it's 113 squared times 37 times 51 to the fourth, all of that raised to the third power. So that means I have three of the 113 squared. I should have three of the 37s and three of the 51 to the fourth squared. Okay? So that's, if I have three groups of 113 squared, that's 113 squared times 3, that's 113 to the 6th. 37, that should be cubed. And this is 51 to the 4th, 3 times, so 3 times 4 is 12. Yeah. Can you spot the mistake? I spotted it. X squared times y times z to the 4th, all of that raised to the third power. So I'm just going to split them up and make each of them cubed. So look how I did it as easy as possible. Took the x squared and said, okay, that's being cubed. Then I took the y and said, okay, that's being cubed. Then I took the z and said, z to the 4th, and said, okay, that's being cubed. Then I did the part where I multiplied the powers. So 3 groups of 2 of x squared is 6. Y cubed is just y cubed. And 3 groups of z to the 4th, that would be z to the 12th. So basically, we're just raising to the power, doing each one separately. So it becomes nice and easy to follow what's happening. All right, can you show me? Remember this one back here? Can you show me using this type of terminology how we go to 2 times 3 times 7 to the 4th power becomes 2 to the 4th times 3 to the 4th times 7 to the 4th. Can you do the same thing for x, y, z? Can you do the same thing for x, y, z to the nth power? Okay, basically the same thing, except instead of saying 4, you're going to say n. Okay. All right, word problem for you. Darlene said 3 to the 4th. Darlene says 3 to the 4th squared, 3 to the 4th raised to the 2nd power, equals 12 to the 6th. Is she correct? If not, can you explain what she did wrong? Did she add the powers or did she multiply the powers? And what should she have done? So if this is 2 groups of 3 to the 4th, that means I've got a 3 to the 4th times 3 to the 4th. And then if we do that, then I would add 4 plus 4, which would give me 8, not 6. Plus, where the heck did that 12 come from? Right? Where did that 12 come from? So she was all confused. All right, homework, practice, practice, practice. A lot of practice stuff. If you don't get this, get some practice in.